Hello everyone. So in the video we are going to see about HCF and LCM. So HCF and LCM is a very common term for all of us. In the HCF and LCM தெரிஞ்சுக்காம படிக்காம நம்ம higher standards or next levelக்கு போயிருக்கவே முடியாது. So இந்த வீடியோல இன்னும் கொஞ்சம் detailed like HCF and LCM உடைய applications ஒரு rapid information list and அதோடைய basics இது எல்லாத்தையும் சேர்த்து ஒரு combined ஒரு வீடியோல பார்க்க போறோம். Let's get into this video. So to start with, I would like to explain what HCF is and what LCM is. So HCF அப்படினா highest common factor and LCM means least common multiple. So factors and multiples ஓட வீடியோவை பார்த்திருந்தீங்க அப்படினா this must be still clear. If not, factors and multiples உடைய videos உடைய லிங்கையும் இதுல போஸ்ட் பண்றேன். அதை பார்த்துட்டு you come back for this for better understanding. But then to understand HCF and LCM, I believe this video is actually fair enough because we are going to start from the basic and make it a very clear path to further applications. So let us start with the basics as such. So HCF, like highest common factor of 12 and 15. So this is our first agenda. So let's say 12 and 15. இப்போ 12 and 15, I'm going to take 12 and 15 here and go for a prime factorization. இப்போ suppose 12 and 15 ரெண்டுமே ரெண்டுமே divisible ஆகக்கூடிய ஒரு number I'm going to consider. So if I'm going to take 2, 12 is divisible by 2 but 15 is not divisible by 2, so I won't take that. So the next prime number is 3. So 12 is divisible by 3 and 15 is also divisible by 3. So I'll take 3 here. So when I take 3, 12 divided by 3 gives me 4 and 15 divided by 3 gives me 5. Now here 4 and 5 are co-primes. They don't have any common factor other than 1. So I'll stop factorizing at this point. So the only common factor for 12 and 15 is just 3. So HCF of 12 and 15 is 3. Right? We can also take another random example. Let's take 25 and 50. So I'm going to take 25 and 50 here. So 25 and 50. So both are divisible by 5. So I'll take 5, 5 and this will be 10. Again 5 and 10 are divisible by 5. So I'll take 5. So here it is 1 and 2. So 1 and 2 I'll stop in this place. So the product of these two numbers, that is 5 and 5, 25. So 25 is the HCF for 25 and 50. Okay. So we will be, factorizing, prime factorizing. The moment we get a co-prime pairs or co-prime set of numbers, so we'll stop at that point and the product of all these numbers on your left hand side is the HCF of those particular numbers. Now let us get on to LCM. So LCM is also of the same order. So we are going to take 12 and 15 here and we are again going to start with the same factorization, prime factorization. So let us take 3. So 3, 4 and 5. See, in the previous case, the number which is a common factor between these two numbers is the HCF. Whereas least common multiple, so we are going to talk about multiple. The product of all the numbers here is your LCM. That is the product of this particular curve is your LCM. That is 3 into 5, 4 into 5, or I'll put it over here 3 into 4 into 5. So which will be 15, 4, 60. So 60 is the LCM, that is least common multiple of 3, 12 and 15. The same procedure is applied when we go for 25 and 50 as well. Okay, so let us go to the next slide for better understanding or take another example, advanced example. So here this slide is all about finding HCF of 24, 36 and 48. Let's do the same thing. 24 we can put 36 and 48. Now I want all of you who are watching this video to take out a pen and pencil and start working out with me. So let me start with the 2. So 2, I'll take this will be 12 and this will be 18 and this is 24. So again we can go with 2. So if I'm going to take 2 again, this will be 6, this will be 9 and this will be 12. So now I'm thinking of a number which is divisible by or which divides all 6, 9 and 12. So I'll go with 3. So this will be 2, this will be 3 and this will be 4. Now even if I'm going to take 3 is not divisible by 2. So I can't do that. So 2, 3 and 4, they are co-primes. Of course, 3 is, I mean, they don't have a common factor. All the 3 doesn't have a common factor. So I'll stop here. And the product of these numbers on my left hand side, that is 2, 2 and 3. Okay, so the product of 2 into, I mean 2, 2 and 3 is the HCF of 24, 36 and 48, which is 12. Okay, so 12 is the HCF of these three numbers, the highest common factor for these three numbers. The same is the case we are going to do with LCM. Let's see the difference. So again in this, the LCM of 24, 36 and 48. So let's do that. 24, 36 and 48. So the same thing we can continue. We'll start with 2. So this will be 12, this will be 18 and this will be 24. So again we can go with 2. So this will be 6, will be 9 and this will be 12. So let's start with 3 now. So this will be 2, this will be 3 and this will be 4. So I don't stop here, I'll still take 2. I'll have 1, 3. I just put 3 as such because 3 is not divisible by 2 and this will be 2. So now we can take the product of all these numbers. So here I cannot take the product because 2 and 4 still have a common factor. So I won't do that. So I'll factorize them until and otherwise I get a number which doesn't have a common factor between them. Okay, so now the product of all these numbers, that is 2 into 2 into 3 into 2 into 3 into 2. So this is my LCM. So this is 4 and this will be 6 and this will be 6. So 36 into 4 is my answer. So 36 into 2 gives me 72. 72 into 2 gives me 144. So the LCM of 24, 36 and 48 is 144. Now let's move on to HCF and LCM of fractions. So it's a very common understanding that the HCF, see, let me just give you an easy method to memorize. So HCF of fractions will always have HCF of numerators by LCM of denominators, whereas LCM of fractions will always have LCM of numerators by HCF of denominators. So this is your dominant part. That is, if it is a HCF of fractions, you'll have numerators HCF and denominators LCM. If it is LCM of fractions, you have numerators LCM and denominators HCF. So that way you can memorize. Let us solve some questions based on this. So let's find the HCF of the following fractions. So as we know, HCF of fraction is HCF of numerators. So I'll just write NR for numerators by LCM of denominators. LCM of denominators, isn't it? So let us just apply the same thing. Now this will be HCF of the numerators of 4 by 5 and 5 by 18 are 4 and 5, and the denominators, see LCM of denominators are 5 and 18. Okay, so this way we can easily solve. So HCF of 4 and 5 of course they are co-prime, so HCF 4 and 5 is just 1. So I'll directly take this as 1 divided by LCM of 5 and 18. So 5 and 18 doesn't have a common factor between them. So they are again co-primes. So LCM is nothing else but the product of them. So 5 into 18 gives us 90. So the answer for this, that is HCF of 4 by 5 and 5 by 18 is 1 by 90. So same way let's do this. So this will be the HCF of 6 and 5, which is just 1, and the LCM of 5 and 12. So let's try to find the LCM of 12 and 15. So 12 and 15 I'll take here. I can easily go with 3. So this will be 4 and 5. So co-primes, I'll directly take 3 fours. 12 into 5 gives me 60. So the LCM of 12 and 15 is 60. So the HCF of 6 by 15 and 5 by 12 is 1 by 60 indeed. Same way, let's try the LCM of the fractions. So this is again, see LCM of fractions is always given by LCM of numerators divided by HCF of denominators. So let's work on that way. So LCM of numerators, LCM of, or let me on the first sum, LCM of 4 and 5 divided by HCF of 5 and 18. So this is again very simple. 4 and 5 LCM is just 20. So this I can write as let me write it here, 20 divided by HCF of 5 and 18. 5 and 18 doesn't have any common number, so their HCF is just 1. So 20 by 1, which is 20. So LCM of this fraction, the first fraction is 20. Let's find the LCM of the second fraction. 6 and 5 is again 30 divided by 5 and 12. So you can take the LCM of 5 and 12 as 3. So 30 by 3 gives you 10, and that is the answer. I hope this is helpful. So here again we have another a very common application of HCF and LCM for two numbers. This is applicable only for two numbers. So HCF of two numbers, or let's say A and B into LCM of A and B, will be equal to the product of the numbers, which is just A cross B. So let us take the same example that we took in the beginning. In the beginning, I believe we took 12 and 15. So let's take the same number. And let us just say we know the HCF and LCM of 12 and 15. Let's take example is like this. So I'm going to assume saying the HCF of 12 and 15. Okay, the question goes like this. HCF of 12 and 15 is, so as we know the HCF is 3. Find its LCM. Find its LCM. So according to this rule, we can directly write that HCF is 3. So 3 into LCM of 12 and 15. So 12 and 15 should be equal to the product of the numbers, which is 12 into 15. And in order to find the LCM will be equal to 12 into 15 divided by 3. I can directly take this or take this as 5. So 12 into 5 is my LCM. So this is nothing else but 60. So this is something that we had already found, but this is just again for a bit proof. So LCM of two numbers into HCF of two numbers will be equal to the product of the numbers. Moving forward. So this is another application. 3 bells ring at intervals of 4, 7 and 14 minutes. All the 3 bells rang at 6 a.m. So they first rang at 6 a.m. When the the three bells, that's again bells, when will they ring together next? That's your question. So all the 3 rings at 6 a.m. So what will be the next time that they ring together? So that is the question. And the hint is that this rings for every 4 minutes. So 4 minutes it rings, and then it is going to be 8, and then it is going to be 12, then it is 16, and then 20, then it is 24. Let me just write down some numbers. 24 and then 28. I'll stop at 28 because I believe you also will be able to find why we are stopping with 28. So the next one is 7. So this rings for every 7 minutes, and the next it rings at 14th minute, and the next it rings at 21st minute, and then it rings at 28th minute. And we know the third bell rings for every 14 minutes. So the first time it rings at 14 minutes, and the next time it rings at 28 minutes. And I'll stop here. So as we all know, this will be 1, 2, 3, 4, 5, 6, 7th. So 7th time the first bell rings at 28th minute. 4th time the second bell rings at 28th minute. And the second time the third bell rings at 28th minute. Ultimately, we wanted to find out at what time it rings, together again. So the next 28th minute, all the three bells rings together. So which means they ring together the next time at 6:28 a.m. That's your question. So this is nothing else but just a common application of your HCF and LCM concept. So we are going to find the LCM of 4, 7 and 14, and that gives you 28. It just means that for every 28 minutes or the next 28th minute, all the three bells rings together. So here is your rapid information list. Let's say, for example, if you are given a question like this, find the greatest number that will exactly divide x, y, and z. That's nothing else but the HCF of the required number is the HCF of x, y, and z. And same way when I say find the greatest number that will divide x, y, and z, leaving remainders a, b, and c respectively, that is again nothing else but the required number is the HCF of x minus a, y minus b, and z minus c. So likewise, you can just go through this rapid information list and just have this in your mind in order to solve questions based out of HCF and LCM. So let's see a couple of questions based on this rapid information list. So the first one is here. Find the greatest number that will exactly divide 24, 36 and 48. Again, that's nothing else but the HCF. So HCF of 24, 36 and 48 is the answer. So we had previously found that the HCF of 24, 36 and 48 is 12, and that will be your answer. So this is nothing else but the HCF of 24, 36 and 48, and the answer will be 12. Moving forward, the next question, find the least number that is exactly divisible by 25, 50 and 100. So this is again nothing else but your LCM. Okay, LCM of 25, 50 and 100. Okay, so let's try to find this. I'm going to take 25, 50 and 100 together, and let me just go for the multiplication. Neither I start with 5, I can directly start with 25. So 25, if I start, this will be 1, this will be 2, and this will be 4. So still I can go with 2. So this will be 1, and this will be 1, and this is 2. So I can directly take this as 25 into 2 into 2, which is 4. So 25 into 4 gives me 100. So the LCM, that is the least number that will exactly divide these three numbers is 100. Okay, so likewise, the rapid information list will give you enough information about questions based on HCF and LCM. Thank you for watching.